Ask your mom and ask your dad. What was the greatest PC game of the 1990s? Minesweeper. A grid waits. Quiet and square. Tiles hide what you cannot see. Some tiles hold mines. One wrong click ends the game. Numbers give small hints. They count nearby mines. Think first. Choose carefully. Clear the safe tiles. Leave the mines alone. Good afternoon. One of the greatest personal computer games of the 1980s and 1990s was Minesweeper. It helped millions of people waste time at work. Today, I am going to explore some sample code. The code is a rendition of the popular game Minesweeper. The code is written in Python, and I am running it on my Raspberry Pi 4. Thank you for watching. This video is going to be long. I attempt a comprehensive explanation of the code. Here it goes. First, I shall provide a simple glossary. Here's a simple glossary focused on the more complex Python ideas that are actually used in this code. First, number 1. 2D list. Grid. A 2D list is a list of lists. This code uses a 2D list to store the Minesweeper board and the visible tiles. Number 2. Sentinel value. -1 for mines. A sentinel value is a special number that means something important. Here, -1 is used to mean this tile is a mine. Number 3. List comprehension. A list comprehension is a short way to build a list using one line. This code uses it to create the board and to count nearby mines. Number 4. Generator expression. A generator expression creates values one at a time instead of all at once. This code uses one inside sum to count how many mines are around a tile. 5. Recursive function. Flood fill. A recursive function calls itself. The flood parenthesis function reveals nearby tiles by calling itself again and again. Number 6. Short circuit logic. And or. Short circuit logic stops checking once the answer is known. This code uses it to safely check board bounds and win conditions. 7. Sets for fast lookup. Flags. A set stores unique values and checks them very fast. This code uses a set to track flagged tiles efficiently. 8. Symmetric difference update. Symmetric difference update adds an item if it is missing or removes it if it exists. This lets the same command place or remove a flag. Number 9. State tracking. First move logic. State tracking means remembering what has already happened. The first variable makes sure the first revealed tile is never a mine. Number 10. ANSI. Escape codes for color. ANSI escape codes change text color in the terminal. This code uses them to make mines, numbers, and tiles easier to see. Let's look at your code in blocks and explain how they work together. I'll keep it simple and focus on the overall flow, not every tiny detail. I'll reference the line numbers roughly as they appear in your code. Number 1. Imports and constants. These are lines 2 to 14. Starting at import random down to reset. What it does. It imports Python modules for random numbers, random, and timing, time. It sets constants for the board size and number of mines. It defines colors for displaying the board in the terminal. Why it matters. Everything else in the game uses these constants and colors. For example, size decides how big the Minesweeper board is. Okay, next we are looking at lines 16 to 23. These are the tile display and symbols. It begins at hidden equals white, etc., and goes down to the def num tile, return red plus f, etc. What it does. It defines how the board looks for different tile types: hidden tiles, flags, mines, empty tiles, and numbers. NumTileN is a small function to display numbers in red. Why it matters? This block just controls visuals. Later functions use these symbols when showing the board to the player. Next is a category called board setup. This is lines 25 to 40, and it starts with def create board, def place mines, etc. what it does. Create board. Makes a grid matrix filled with zeros. Each zero represents an empty file. Place mines. Randomly puts mines on the board, but avoids the first tile the player clicks. Count numbers. Calculates numbers for each tile, showing how many mines are next to it. Why it matters. This is the core game logic where mines are and what numbers appear next to them. Without this, the board would have no gameplay. Next, this section is lines 42 to 52, and it's under the category of revealing the tiles. And the code starts with def flood board visible yx. What it does. This function reveals tiles on the board recursively. If a tile has no nearby mines, 0, it automatically reveals surrounding tiles. Why it matters. This is how the game floods empty areas when you click a safe spot. It connects to play parenthesis when the player chooses to reveal a tile. Okay, next block of code, next section are lines 54 to 73. This category is called drawing the board. And the line of code it starts at is def draw board visible flags start. What it does. Prints the board in the terminal, shows flags, hidden tiles, mines, numbers, and empty tiles. Also prints a timer and a number of mines left. Why it matters. This is the interface for the player. It uses the symbols defined earlier and the visibility state from the flood/reveal logic. Okay, the next section, block of code, is at lines 75 to 92, and this category is called input parsing. And the line of code it starts at is def parse letter S. What it does. Reads player input and figures out if it's a reveal or a flag action. Converts the input into board coordinates. Why it matters. Without this, the game wouldn't know what the player wants to do. It links the player's text input to the game logic. Okay, next section or category is lines 94 to 143, and it's called or categorized as the main game loop, and it starts with the line def play parenthesis board equals create board, and then further on it says while true. So there's a while loop. What it does. This is the heart of the game. It handles drawing the board, reading input, updating tiles, reveal/flag, checking win or loss conditions, starting a timer, and first click logic. Why it matters. It coordinates all the other blocks: board setup, input parsing, tile revealing, and displaying the board. Every turn, the player interacts with this loop until they win or lose. Alright, the last section or category we're going to address is the outer loop, and this is lines 145 to 146, and it's a while loop, and it says while true play parenthesis. What it does, it keeps restarting the game after it ends. Once play parenthesis finishes, win or lose, it immediately starts a new game. Why it matters. Makes the game continuous. You can keep playing without restarting the program. Okay, that covers all the different blocks or section of code. So here's a final overall interaction. First, or number one, is initialization. The constants, symbols, and board setup create the framework. 2, game loop play controls the flow, draws the board, gets player input, updates the board, checks win/loss. 3, functions connect, create board, place mines, and count numbers, set up the board. Flood reveals multiple tiles automatically. Draw shows the board visually. Parse interprets player input. Outer loop lets the game restart endlessly. Alright, so what you are looking at now is a flow diagram of how this game works, and I will read it from top to bottom. So first you start by initializing the game. You create the board, place mines, count numbers, and then it goes to the main game loop, which does 3 things. It draws the board, it parses user input, and it updates the board, flood, reveal tiles. After this, there are 2 different events that could happen. The player could win, or the player could hit a mine. If the player wins, you win. If the player hits a mine, boom, game over. And then the next step is replay.